Hello all, it is Miss Hester again. I'm making a couple of videos over some of the stuff that we've done recently where I was trying out that new kind of classroom called the thinking classroom. And it was where y'all were on the whiteboards and kind of doing the problems yourselves without too much information from me. So I just wanted to go over these just so that you kind of can have them in your notes in case you didn't get them for some reason, or if you were confused on how to do these. So this is what these videos are for. So our first topic, sorry, before we begin, you must like and subscribe to my YouTube channel. But let's go ahead and get started. So the first topic that we talked about was how we apply laws of exponents to rational powers or fraction powers. And the rules of exponents work just like normal. If we're multiplying two bases, we add the exponents. If we're dividing the two bases, we subtract. If we are raising an exponent to an additional power, we multiply those exponents. Okay, so the process remains the same. We're just adding fractions into the mix. Okay, so that's what all of these problems are for. So here we are multiplying our two bases. So we are going to end up adding our exponents. We have x to the 3 over 2 plus 1 over 2. So then that would just be x to the 4 over 2, which simplifies down to x squared. And that's, again, all we're doing here. All we're doing is applying these exponent rules to rational powers. Again, we multiplied these two bases, we add the two exponents. Okay, same kind of thing over here, but the difference here is parentheses were used to represent the multiplication. So when we were doing this in class, a lot of groups made this mistake. They instead multiplied these two things, but we can't do that because our bases are being multiplied. Now, if we had this, then we would multiply our exponents. But because we do not have that 4/3 raising this whole thing, we are not going to multiply our exponents. Okay, we're going to add our exponents still. So we'll have y to the 4 over 3 plus 7 over 3, which simplifies to 11 over 3. Now, in class, I talked about how we can go back and forth between a rational power and a root. Okay, so here we can rewrite this as the cube root of y to the 11th. Okay, so again, whenever we have a denominator here, that is the type of root that we have. Okay, if we have a numerator, that is what we're raising our variable to. I apologize if you hear my dog whining in the background. She saw a bunny. So that is how we can rewrite a fraction power as a root. Okay, whatever the denominator of the fraction is, that's the type of root we have. Whatever the numerator is, that is the power on our variable. Now, we could write this another way. We could write this as the cube root of y, and we raise that whole thing to the 11th power. Whichever one you prefer. I personally prefer this because it's shorter and less writing. But if you prefer this in your brain, great. They mean exactly the same thing. Okay, so that's that. All right, now let's talk about the division. Okay, so again, with division of bases, we subtract the exponents. So we'll have x to the 5 over 4 minus 1 over 4, which simplifies down to x to the 4 over 4, which is just x to the first. And then we're done. We don't do anything else from there. Okay? Now, this last one, we had to do two things. We had to do multiplication on the top first. So I'm going to work on the top first. So we'll have y to the 1 over 3 plus 5 over 3, but we're still divided by that y on the bottom. Okay, when we were doing this in class, a lot of groups did this, which was great, but a lot of groups left it at this. We still have to deal with our denominator. Okay, so I'm going to simplify my numerator real quick. We have y to the 6 over 3 divided by y. Now, 6 over 3 just simplifies down to 2, so we have y squared divided by y. Now, if y does not have an exponent on it here, it is an implied power of 1. So we would just have y to the 2 minus 1, which is just y to the first, or just y, depending on your preference, okay? So here we had to do a little bit of simplification of our numerator first, and then we brought in that denominator. But again, we can't just leave it with this numerator. That's great and all. That's our numerator, but don't forget about the denominator. Again, that was a really common mistake in class. Okay. moving on over. So this one is where we are going to end up multiplying our exponents, okay? Because we are raising everything in this set of parentheses to the 1/2 power, okay? So what I'm going to do, I distribute that onto everything, okay? Including the 16, okay? So the 16, it has a power of a little baby 1. It's not there. And again, if something doesn't have a power, the implied power is 1. So what this is going to turn into, this is going to turn into 16 to the 1/2 power, okay? Because 1 times 1/2 is just 1/2. And then we have f to the 1/2 times 1/2, because again, we are raising this 1/2, this f to the 1/2 to an additional 1/2. So we multiply those two exponents. And then we have g to the 2/3 times 1/2, okay? Now, where a lot of people had an issue here, okay? 16 to the 1/2 is not 8, okay? 16 to the 1/2, I'm going to write out this off to the side. 16 to the 1/2 is the same as saying the square root of 16. Again, going back to that idea of how we can rewrite rational exponents as a root. Okay, this is the same as a square root. We have a 2 for our type of root. So it's just a square root. There's an implied 2 here. And then a power of 1 on the 16. Okay, and we all know the square root of 16 is 4. So our first number here is 4. Again, this is not 16 times 1/2. Okay, this is 16 raised to the 1/2. There is a difference. Okay, then we had f to the 1/4. Okay, when we multiply fractions, we just multiply straight across. Most everyone was able to get that. And then we had g to the 1/3. If you did it without simplification like I did, you would have 2/6, which simplifies down to 1/3. Okay, so again, this process of raising an exponent to additional power and we multiply all of those exponents hasn't changed because we've turned the exponents into fractions. The process, again, remains the same. Okay, so our answer here was 4f to the 1/4, g to the 1/3. Okay, now a lot of people had a good amount of, I heard a lot of good conversations about this one in all of my classes, and I really, really liked it. Okay, what I would do, there's a lot of different ways you could do with this problem. Okay, what I would do first is I would distribute this exponent in. Okay, so I'm going to bring in my 2. And again, I'm raising it to everything inside the parentheses. Just because there's a fraction here doesn't mean I don't raise this 1/3 on the bottom to that second power. Okay, so I will have 42 to the 2/3 divided by 6 to the 2/3. Now, a lot of people, when they were doing this problem, and it was most groups, would say that this is 7. Okay, it is not 7. In fact, if we plug this into the calculator, so if we do that real quick, let's see, we have 42 raised to the 2 divided by 3 divided by 6 to the 2 divided by 3. And if we notice, that gives us a really, really nasty decimal. That's 3.659, blah, 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 blah. Okay, so that is definitely not 7. Okay, now a lot of people, the reasoning for putting 7 was very good reasoning. 42 divided by 6 is 7, and when we are dividing bases, we subtract the exponents. Okay, however, these two bases are not the same. This is not like x to the 2/3 divided by x to the 2/3. Okay, these two bases are very, very different. 42 is not the same as 6, so we cannot subtract exponents here. But we can still divide those numbers because the exponents are the same. Okay, and we kind of got into this a couple of classes later, but this is saying 7. We're going to divide 42 by 6, but we cannot just say 7. It is 7 to the 2/3. Okay, and if we plug that into our calculator, just to double check ourselves, make sure we didn't do anything wrong, we have 7 to the 2 divided by 3, and that gives us the exact same answer. Okay, so again, a lot of people, I heard a lot of really good discussions with this one, so I was very pleased with this question. But again, these two bases, 42 does not equal 6, so we cannot subtract these exponents. But because these exponents are the same, we can still divide these numbers. Now, let's say we had 42 to the 1/3 divided by 6 to the 1/4. We can't do anything to that, okay? As of right now, we don't know how to do that kind of problem, okay? This would not be 7 to the something. This would just stay this. We can't simplify this as of right now, Okay, we'll talk maybe a little later about how we can deal with that, but that we couldn't do. But because these exponents are the same, we're able to do this, okay? So our answer in this case was 7 to the 2 over 3. Okay. This one was pretty straightforward. You just had to do a little bit of PEMDAS. So a lot of people tried to multiply these first. Again, exponents comes before multiplication in PEMDAS. So I'm going to bring that exponent in. So this is x squared times x to the 3 times 3 over 5. Okay, so this was x squared times x to the 9 over 5. Okay, because 3 times 3 is 9. And then the 5 stays on the bottom. So then we have x to the second plus 9 over 5. Okay, now if I have a number plus a fraction, I have to make sure they have the same denominator. So this is like 2 over 1 plus 9 over 5. So then we have 10 divided by 5 plus 9 over 5. And that is the same as x to the 19 over 5. Now, again, I wanted you guys, if you ended up with a fraction power in your answers, I wanted you to convert this to a root. Okay, so we have a fifth root because our denominator is 5. X is our variable, and it has a power of 19. Okay, if you wanted to write it like this, we have fifth root of x raised to the 19th, completely up to you. They are exactly the same thing. Okay, so that is how we applied exponent laws to rational powers or fraction powers. Okay, the process remains the same. If we multiply the two bases, we add their exponents. If we divide, we subtract. Okay, if we're raising exponents to an additional power, we're going to multiply those exponents. And then this guy was tricky. Okay, if our bases are different, we do not subtract if we're dividing. Okay, but if our exponents are the same, we can still divide, but we keep that exponent on there. Okay. All right. I hope this video helped. If you were confused on how to solve using roots, please watch the next video. That's what the next video will be over. I hope this helped.